So let's use this idea to actually approximate a specific value. Now, I don't know what the square root of 10 is, but I do know what the square root of 9 is. So this is going to be clearly a little bit bigger than the square root of 9. So I need a known point to figure out what this value is. So that known point is going to be, well, the function I'm going to use is f of x equals the square root of x. And I'm going to try to approximate this function near x equals, or let's say a equals 9. Because I know the square root of 9 is equal to 3. So I now have my point. And my point is 9, 3. So I want to take a look at the first derivative. F prime of x equals 1 over 2 root x. I want to evaluate this at my known point 9. So this is going to be 1 over 2 times the square root of 9, which is 3. This is 1/6. So I know my linear approximation, y, is going to be my known point, which is 3, plus 1/6 x minus 9. See, this has the form y equals f of a plus f prime of a x minus a. That's my linear approximation. So let's just evaluate this. I'm going to take this y and get rid of it. And I'm going to go back to the notation we're using for the Taylor polynomials. So this is going to be p1 of x. So the first degree our Taylor polynomial evaluated at 10. This is going to equal 3 plus 1/6 times 10 minus 9, which equals 3 plus 1/6, right, because this is just 1, which equals, what, 19/6. Now, if you grab a calculator, you see that 19/6 is approximately 3.1666. Now, if I grab a calculator and find root 10, you get, let's see here, square root of 10 is approximately 3.1622. So this is not a bad approximation. It went out matching perfectly 2 places. So let's go ahead and improve it. See, f double prime of x is going to be equal to, see, 1/2 x to the negative 1/2 prime. I'm taking the derivative of this, which is a negative 1/4 x to the negative 3/2, which I think I want to write as negative 1 over 4 times the cube. Whoops, that's not the cube. It's the square root of x cubed. Which of course negative 1 over 4x times the square root of x. And I'm going to evaluate this at x equals 9. So this is going to be negative 1 over 4 times 9 times 3, which is a negative 1 over 108. So my second degree approximation is going to look like 3 plus 1/6 x minus 9 minus 1 over 108 x minus 9 squared over 2 factorial. And now if I evaluate this at x equals 10, so P2 of 10 equals, well, I already know what this piece is. This piece I said a few minutes ago was 9 or 19/6 minus, well, it's 2 factorial, that's just 2, so it's 108 over 2, I'm sorry, 108, 1 over 108 times 2, which is 1 over 216. And then, of course, at 10, this is just 1 squared. So this is going to be equal to 683 over 216, which, if I put in a calculator, is approximately 3.1620. So now let's look at our approximation. Here is the actual out to 4 places with a calculator. This is a linear approximation, which matched really nice, these first two. And now here's my quadratic approximation, which matches perfectly out 3 places. And of course, if I keep going with this, I can get a better and better approximation.